In this following example, an insurance company is concerned that men are more likely to speed than women. So in a sample of 500 randomly selected women, 27 have been ticketed for speeding in the last year. In a sample of 250 randomly selected men, 26 have been ticketed for speeding in the last year. Using a 0.05 significance level to test the insurance company's claim that the percentage of women ticketed for speeding is less than the percentage of men. Okay, so let's state the null hypothesis and alternative hypothesis for this scenario. And actually, before I do that, let's define what P1 and P2 are. Because here we're talking about two groups. One is a group of men and one is a group of women. So let's let P1 be the proportion of women that get speeding tickets. And then we'll let P2 be the proportion of men that have gotten speeding tickets. Okay, so our null hypothesis will always be that P1 and P2 are equal. But our alternative hypothesis, we have to think what we're claiming here. So the insurance company claims that the percentage of women ticketed for speeding is less than the percentage of men. And in this case, P1 would be the proportion of women. So we're going to be claiming that P1 is less than P2. Okay, now before I write the test statistic, let's collect our sample data here, because we've got two samples. So we'll have essentially two of everything. So we'll have one for P1 and one for P2. And let's see, so we're looking at a sample of 500 between them. I'm sorry, a sample of 500 women, just women, so that would be 500 in the sample for P1, where 27 of them have been ticketed, so X1 would be 27. And in a sample of 250 men, so here our sample size for the second population is 250, 26 have been ticketed. Okay. And we're going to be using a 0.05 significance level. And for the test statistic, we can remind ourselves how that's computed. So we're going to take the difference between our point estimates and then subtract that from the difference between our claimed proportions. And in this case, remember that because our null hypothesis is that they're equal to each other, this part will always be 0. And the denominator will have P bar Q bar over N1 plus P bar Q bar over N2. Now, before we can use this formula to find the test statistic, we would need a couple of things. We would need P1 hat, P2 hat, and we would also need P bar and Q bar. So let's see how those values would be computed. So P1 hat, which would be X1 over N1, so 27 over 500. Would give me a value of 0.054. And then for P2 hat, we're going to do x2 over n2. Should be 26 over 250. That gives me a value of about 0.104. Now let's compute P bar and Q bar. So P bar, remember, is the combined samples. So 27 females, 26 males. And then the total was N1 plus N2, so 500 plus 250. That gives me 53 over 750, which would be 0.0706. 0.0706. Repeating. So then we basically have everything we need to plug into the formula. Of course, we also need Q hat, or Q bar, I should say, which will be the complement of P bar. So 1 minus 0.0706. Gives me about 0.929. Okay. So we can then put all the values in. We know P1 hat minus P2 hat. We can use those values that we calculated here, 0.054 minus 0.104. So then down below we've got P bar, 0.0706. Q bar, 0.929 over N1, which was 500, plus 0.0706 times 0.929 over 250. Okay, there's the formula in all its glory. Notice this is a very complicated formula, and we're going to have to punch this all into our calculator as it is. But it's worth pointing out that because this can be very tricky to work it all out by scratch every time we do this, our calculator would do this for us with a lot less messy arithmetic. So why don't we explore that a little bit here before we move on. So to do this on our calculator, we're going to go to tests and look at 2samp z-test. Or I'm sorry, 2prop, not 2samp, 2prop z-test. Here we're comparing two proportions, so that's why we're going to do 2prop z-test. Z-test. Okay. And when I open 2prop z-test, notice that what it asks for are the values that we've already kind of indicated over here. It asks for x1, it asks for n1, and let's see, it asks for x2 and n2, values that we got over here. And then the form of our alternative hypothesis was P1 is less than P2. So we'll just select less than P2. And that's all the information that it needs. And then it'll compute all this for us without us having to punch all this into our calculator and get a very messy formula as a result. So in the next slide, I'll have the values where we've punched all this in to get our test statistic and our p-value. So now that we've punched all that into our calculator, we found the test statistic was a z-score of negative 2.518. So let's go ahead and graph that. Where would that land on our axis here? So maybe we're out there, negative 2.518. So the p-value that we compute would be the area below that test statistic. Because in this case, remember, we're doing a left tail. And the p-value that we get was 0.00588. Okay, so it's a very small value for p, and since it's much smaller than the significance level of 0.05, right, we're able to reject the null hypothesis. So let's see, what does that tell us about the original claim? In the original claim, we were saying that the proportion of females that receive speeding tickets is less than the percentage of men. And in this case, since we were able to reject the null hypothesis, we have evidence to support that claim. That P1 is less than P2. In other words, fewer women get speeding tickets than men.